So, what Newton's law of universal gravitation is about, let me just write something. Um, Newton's uh, Newton law of universal universal. What's wrong with this thing now? Gravitation. So basically, in this law, it just states that every mass attracts every other mass, and the force between those two masses is directly proportional to the product of the masses and inversely proportional to the square distance between the masses. So do you understand
Repeat
what
the
this
definition
means?
again, sir. I'm busy writing it down.
Okay. So um let me just illustrate it and then I'll say it again.
Yes, sir.
Okay, so at least you understand what I'm saying, sorry. So if you have a mass here and you have another mass here, what Newton's law of universal gravitation states is that this mass is applying a force on this mass. So let's say it's an attractive force. So this mass, let's call it M, and this, let's call it N. Now, M is gonna apply a force on N, and M and N, why L M A B A B A B? I think AB is better. Uh, because if I use M and N, it might end up sounding like I'm saying M instead of N. And so what happens is that A is applying a force on B, and B is applying a force on A. Yeah? That's what Newton's law of universal gravitation states. It states that this mass is going to apply a force on this mass, and this mass is going to apply a force on this mass. So that force can either
Yeah.
be attractive or repulsive, né? Depending on what you're on the situation. And then what that means is that this force, the force that's the force in between the two masses, né, is gonna be directly proportional to the product of the masses. And when we're saying the product, that means like you're gonna take the mass of A and the mass of B and multiply them. So we're gonna have a force in between the two objects, and that force is directly proportional to uh, the product of the masses. So I'm gonna say MA. So we use small letter M for mass, and then MB. But this force is also indirectly proportional to the square distance between the two masses. So 1 over, and we're going to use D for our distance, D squared. So let's go again. Newton's law of universal gravitation states that each mass in the universe applies a force on an each other, not even each, another mass in the universe. The force between the two masses is directly proportional to the product of the masses and inversely proportional to the squared distance between the masses. So did you get that?
No, sir. Like
Sorry?
I didn't get this, sir.
Okay. So what it states is that every mass attracts every other mass in the universe. Ne? So the force is
Sir.
is the attractive force. Ne? Did you get that part?
Yes, sir.
With a force that is directly proportional to the product of the masses and inversely proportional to the squared distance between the center of the masses. Because, when we're dealing with like large objects, we're gonna need to deal with the centers and not only like the distance between the two objects. We have to deal with the centers of gravity on the objects. So did you get that? Did you understand that part?
Inversely proportional to the centers of the masses.
It's inversely proportional to the square
Yes, sir.
distance between the centers of the masses. You have to be very precise when you're stating something in physics. Very precise.
I wrote down the definition, sir.
Okay. So now we're gonna go back to this. So since you see that this is directly proportional to the product of the masses and inversely proportional to the distance squared, so that means F, nah, you're just
Yes,
gonna
sir.
write your direct proportion, and it's gonna be A, shit, B, and here you're gonna divide it by D squared, right? Because of these two equations here, because of this and this, nah? You can see like you're
Yes,
just
sir.
gonna take one MA, MB, multiply it by 1, it's gonna give you this, right? But the thing is, nah, there's always a constant. So what you're gonna have, this is not the actual equation. The actual equation is gonna include the gravitational constant. So when you're gonna remove this sign, it's gonna change into F is equal to our gravitational constant multiplied by MA multiplied by MB divided by D squared. And our gravitational constant is equal to, was it 6? Let me just check it again. 6.67 times 10 to the exponent -11. And the units for our gravitational constant is gonna be meter cubed multiplied by kilo per kilogram per second squared.
So must you memorize that for the exams?
You
Or
mean
do they give you the formula?
you mean the you mean this part?
Yes, sir. Yes,
Nah,
sir.
this part, it's a gravitational constant. They will always give it to you. If
Okay.
you are gonna have like a formula sheet, obviously they give it to you. Even this formula as well, they'll give it to you sometimes. You see,
Yes, sir.
but it's a fairly easy formula to remember. So basically, that's it. So what you need to know about Newton's law of universal gravitation, you need to know the formula, and there's also this other formula. What's that formula? There's also this other formula when you're calculating the force of the earth. Let me just check it because there's two formulas. There's another one where you're gonna say F is equal to GM. Oh yeah. GM divided by D squared.
The same formula apply for
Sorry?
5 MAB, sir. So does the formula also apply for like B, sir?
Yeah. Now I get it. What
Okay.
you're doing this, sorry, I'm actually just used to like saying some stuff in my own language. So when you're doing this, no, they're gonna say, let's say they want you to calculate the force of the earth, and then they will give you the objects. That's why I'm just saying like MA, MB. It just depends on the objects that they give you. So I don't know. Let's just try maybe like a simple question. I want you to try and do this for me. Why?
Yes,
Let
sir.
me just try. Let me undo that. Yeah. Let me leave this formula here. I'm just gonna leave it in the form of units and then cover it like this and cover these like this. So I'm pretty sure you can write on the whiteboard, right? I just want you to write somewhere here in the middle. So what
Yes,
we're
sir.
gonna say, what we're gonna say is that you remember during 2020, it was social distancing and stuff like that,
Yes, sir.
So let's say you're in a line, like as you're in the shopping mall, you're trying to get something, and here you are, you're in the queue, and um here's someone standing here in front of you. So you remember how far you must social distance from someone else, né?
Yes, sir. 1.5 meters.
Exactly. So you already know. Can you calculate the force of attraction between you and that person? I gave you the value of G. I gave you the formula here. So let's say this person weighs 40 kilograms or whatever. It's you and me. I personally weigh, how much do I even weigh? I weigh 68.5 kilos.
Calculate for both, like A and B.
Sorry?
You have to calculate the force for both.
The force, when you have two objects, you're gonna use this one. When you have one
Okay.
object, you're gonna use this one below. So this is
Okay,
for
I
two
understand, sir.
objects, and this is for one object.
So is the weight 40 or 68.5?
This is for me. I weigh that much, and this is you. So calculate the force between us using your knowledge of like COVID, of the COVID restrictions. And you said the distance between us is supposed to be 1.5 meters. So
Okay.
try to show your calculations. I'm gonna make this here, this little square here. Try to show your calculations.
So
Are you able to write on the whiteboard?
yes, sir.
Okay. Then let's
I
just say
believe.
I'm not here, nah?
Yes, sir.
And this is an exam situation. So try it.
So must I use the weight?
Use your
Just
math. I gave you
there's
my
only weight
math.
by like one of the values.
Sorry?
What must I write, sir, by like MA? Was there
By
only like
MA,
MP's
it
value?
doesn't matter. Like you can say the thing is you're gonna have to say you see this subscript, nah?
Yes, sir.
It's just there for to indicate that okay, it's this person, okay, it's this thing.
Okay.
So basically you can write MJ for Jason and
Yes, sir.
you can call me Seth, you can call me. So this doesn't matter.
Okay.
Shit, what's happening now?
I understand, sir. It's very difficult drawing on the board, sir. Yeah.
You're using your laptop.
Yes, sir.
Oh, uh, why is this thing not switching off now? Now you can try to write it down in text. Well, how about you do this now? How about you calculate that by yourself, now? And you give me the answer for the force.
Yes, sir.
Because I personally I think at this point I'm used to writing with my touchpad. So that's why it's easier for me. But I know how difficult it is to write using a touchpad
So what's D square?
calculator. D squared.
Yeah.
Just write your answer, man. And see. D squared is the distance between us.
Oh,
The distance between us squared. So, what you know
okay.
is
Then
that
what's M squared, sir? What's M cubed?
M cubed.
Yeah.
No, there's no M cubed here.
So you give me the formula that G equals 6,67 times 10 to the power of negative 11
M
M
cubed
cubed times
meters,
G.
cubed meters, which is the volume of the object,
Yes, sir.
and per kilogram, it's volume per mass per second squared. And second squared, that's for, you're gonna end up with like this and this giving you m squared. It's gonna cancel out that other don't worry about those units, just worry about the units of the final answer. So what's your final answer? Can be 50.
So my answer is 1,28 times 10 to the power of negative 11.
How many zeros do I have? Times 10 to the power
You have 11
11.
zeros before they get to the ones and so on.
I got 10,153 times 10 to the exponent negative 11. So I'm pretty sure, I think I know where you made your mistake. So, oh, we have 6 minutes. Okay, 6 minutes is enough. So we're gonna go first write our equation. We're gonna have F is equal to G, the mass of
Yeah.
Jason, the mass of Seth, which is me, and the distance between us squared. So what you're gonna end up with is, I'm just gonna write G because I don't want to write this again. G, which is 6.67, all of that into our mass, it's gonna be 50. And here it's gonna be 68.5, right? And we're gonna be divided by 1.5. And what you do is, it's gonna be 1.5 squared, because as you can see, it's d squared, 1.5 squared. You understand that part?
Yes, sir. So is the G constant just 6,67 times 10 to the power of negative
Every
11?
time you see G, it's 6.67 times 10 to the exponent negative 11. When
Okay,
coming to
so because the one on the
Newton's
screen,
law.
so because the one that you had on the screen was that, sir, and then they said M cubed times kg minus to the power of negative 1, and then S
Nah,
to the power of negative 2.
we're just gonna deal with numbers for now, because I don't want to confuse you with the units. Like,
Okay.
when coming to units, you'll worry about units if you're gonna do physics in varsity. I have to worry about units. They don't care as long as the unit of the final answer is correct. You see,
Yes, sir.
so put this into your calculator: 6.67 times 10 to the exponent negative 11. 5, that and that. Let me check my answer again. 6.67 times 10 to the exponent negative 11. 50, 68.5, 1.5, the whole thing squared. That's gonna give me 1, 2, 3, 4, 5, 6, 7. 7 zeros times 10. I end up with is equal to 1.01 02 newtons. So did you get the same answer? Or maybe is my calculator crazy?
So I didn't get the same answer, sir.
Mm.
Because I got 1522,2222.
Mm. Did you substitute this here?
No, sir. I
For
think that's
G?
why.
Oh, okay.
I don't think I substituted it in, that's why.
Let me just write it this side then.
Yes, sir. I got the same answer as you, sir. I
Okay.
substituted in the G,
Okay.
and I got it.
So that's basically how we're gonna be working with Newton's law of universal gravitation. So what I'm gonna say, is that this is just this is an easy question, as you can see, but this is the type of question that you're gonna get
Yes, sir.
asked. So, oh, okay. Now I remember the other question, the other formula. So, let me just stop recording.